Okay, and our last one for the moment is value to time. Value to time is very interesting because it allows you to do translations between values. Let's say you wanted to say, okay, my value coming in, whatever it may be, maybe it's a particle age. So this particle age, we're going to expose, pipe it in here, and we're going to say, okay, value to time. The value coming in, if it's between 0 and value 2, let's say 100, the value coming in, if it's between 0 and 100, I want to output a time between 0 and 30. So if the value coming in is 0, the time going out is going to be 0. If the value coming in is 100, the time going out is 30. And that's an actual time value. Time, it can be used as time. It can also be used as a scalar or float. Okay. But then here's what happens. If the age is 50 and it comes in, then what happens is we look up between 0 and 100. What's 50 there? That's 50%. So we look at 50% between time 1 and time 2. So it'll be 15. What's really interesting, that's a very linear kind of calculation, and we can force these. These stop buttons prevent them from continuing. Say the value coming in started off at a negative 100. It would actually do a linear calculation if we left this unchecked. And it would say, okay, well, you said that I should go from 0 to 100, but I'm actually starting at negative 100. So from 0 to 30, I'd probably start at negative 30. And as I approach its value of 0, my time would rise to 0. So it is a linear calculation. But you can do something very fun with this. It's extremely useful. We've got it saved here called GraphOp. And what GraphOp will do, duplicate that. GraphOp allows us to take a value, let's say it's his age, and we've got it set up so that it's from value 0 to 30. So his age from 0 to 30, we're going to output time 0 to 100. Okay, so that time, as this particle ages from 0 to 30, that gets fed into here, and it's getting translated into a time value. And so this fade in value then, you see he's got a time input exposed? He's getting the time value that's value to time is outputting. Value to time is going to output from 0 to 100 over the course of the particle age being 0 to 30. Oops, 0 to 30. So as the particle ages 0 to 30, value to time is spitting out time 0 to 100. 0 to 100 comes into fade in. Fade in's time is going to look up what his current value was at that time. Because fade in, this particular fade in is animated. So you can see his value changing as we go. What happens here is, and actually we're going to go ahead and create a simple example for this. Because GraphOp is really one of the best ways if you ever need to blend values in and you want exact control. This is the way to do it. For some reason this dynamic set is not playing nice. Let's do this. Let's draw some particles. We just need, we'll go ahead and make their time a little different. And let's get a size shape black box. Just need that one and this one. Okay, so we've got our first rule there where we're boarding some all particles, and we don't need those right now. We want to affect the all, we want to affect their age. Remember, this is going back to that GraphOp value to time example. We're going to take their age, and so value to time is going to calculate when the value is between 0 and 30, going to output between 0 and 100. That gets fed into fade in's time input. Fade in is an animated value, so it's going to take whatever time he receives from this translation and says, okay, my value at that time was whatever this value is, and he's going to output it. The way this works, we'll just go ahead and hook it up and then take a look at it. We're going to connect the particle size, and we're going to take that value into the size. Yeah, this is not a very... let's see, let's change that age, and we'll just modify this a little bit. We're going to see the pass-through of the float here too. The reason we're having a problem is our fade-in is it's only animated a value of 0 to 1. And so what we need, if we're going to pipe that into size, it doesn't really make sense to have a size from 0 to 1. We're going to actually want to take that value, multiply it by, say, 10, or let's do 20. And then we're going to pipe that output into the size. So what you see happening here is, as the particle gets older, he does this translation, says, oh, my age is approaching from 0 to 30. Look up the corresponding time. Pass that time out here. Comes into fade in. Fade in says, okay, at this time that I'm receiving, my value is such and such. Output that value to the float. Float multiplies it by 20, passes it back into the particle size, and he scales up over time. The reason this makes for great control is if we come here to this fade in is really just a float that's been renamed. And what we want to do is right click in this field and say show in track view. What we'll see after we get our view sorted out. Okay. What we'll see is that we've got a curve here. This is just a curve that we've done by hand. You can go ahead and add extra keys in here, and it will actually change what the particle does over time. You can see that it goes up, then down, then up. The particle age is going to go ahead and do that same kind of time lookup here. And so this value at a time, it's saying output time 0 to 100. Well, that 0 to 100 corresponds to what we have here in this graph. We start at 0, and we end, this key up here is frame 100 at 1, value of 1. So whatever value time I'm being told to look up here, if I'm being told to look up, hey, what's your value at 48? Well, my value at 48 is right here. So go ahead and output that value. Comes into float, gets multiplied, sent out to size. So this is a fast and easy way to go ahead and be able to do things like use the handles on these Beziers to go ahead and sculpt whatever kind of action curve you want. So that is the basics of the graph op, which is a great way to, if you wanted to fade in gravity over time, any kind of fading, fantastic way to do it.